here are hopefully some nice answers for us. So one thinking is C, and if C is true, then E had better be true. Two, I've got a graph, not nearly as good as Shirley's. Oh, she's even making it better. Mine's got all the parts, but it's not as artistically good as hers. Very lovely graph. Then, yeah, 3 is a product rule with a chain rule sandwiched in there. I didn't simplify very much. Figured I would just leave it like that so you can maybe see we have a good point of comparison. Okay. So this is a fantastic opportunity for you to say, wait, why does the graph look like that? Or why is it C and E? I don't know, whatever. Do you have any questions? Sir.
Why is the graph of the derivative, why from -2 to 2, why is it parabola and not line? Is it because it's a cubic?
We're getting a little bit into like probably too specific of an interpretation.
Okay.
Somebody wanting to do that, wanting to go there, I think what you could do is you could look at this part of G and say, well, if anything, that sort of looks like a cubic, and the derivative of that would be a quadratic looking thing, and so sure, this would be believable from that perspective. And to be honest, probably in Desmos, I probably either used a tangent graph or a cubic graph to make that G of x. So that's probably a reasonable interpretation, but I'm not going to get too hung up on that. I'm just going to say, where's G prime 0 or undefined, where's G prime positive or negative, and then I'll try to make a nice curvy
I just kind of looked at it.
interpretation.
Maybe it was like 2 halves of a quadratic with a line.
Yeah, it's not an unreasonable interpretation at all. Yeah. Luke?
Does the parabola on the G prime of x graph, is that going through 0 or is it just touching?
Bouncing.
Okay. Is that
That's a
is that because there's like a horizontal line in the cubic or what?
yeah. So I probably made a cubic, and I probably made it like a fat cubic to make it as clear as I could. Doesn't it look like right about there, maybe the graph of G does like flatten out for just one little spot, right? So, and right there, I'd say, obviously you can see based on my graph, you'd say that G prime is 0 there. Although, I didn't, in the description, I didn't make that like abundantly clear. So if somebody had put, I don't know, if somebody had come down here and just gotten super duper close to 0, right? Maybe that's reasonable. If I wanted this to be, like a really well-crafted question, I'd probably want to say the graph of G has a horizontal tangent at x equals 0. And you've seen that on some of the quizzes and such. I've tried to clarify what these different features are. So that's what I was going for here. I just didn't really craft it perfectly. Okay, good questions. What else can I do? Okay, so a couple of encouragements then for you before we jump into our activities for the day. Number 1 encouragement is keep/start doing retries as needed. Make sense? Those things are so key. When you get to that unit test we talked about next week, having done all those and prepared and excelled on those quizzes, whether it was on the first try, second try, or third try, whatever, it's going to so prepare you for your test. You're going to knock it out of the park. It's going to be awesome. Okay? And then another word of encouragement or advice, I guess. I would encourage you as we move forward, as we continue to move forward past the unit test in the next week and beyond, as you do have those quizzes, if you do get a grade that you want to do a retry on, would you all agree with me that it's better to do the retry early in the cycle rather than late? The snowball effect of like, oh my gosh, I've got 3 retries versus I got this 1 retry and I already did it last week and oh my gosh, I got another one. Well, at least we're talking about 1 of them as opposed to 3 of them. Second unit only has 2 quizzes. Second unit, the quizzes are derivative skills 1, which we're doing tomorrow, and derivative skills 2, and that's, off in the future ways. So there's only 2 in the second unit. The third unit has like 4, I want to say. Just kind of varies on how many. And then, by the way, if we get into those that have like more quizzes, usually the quizzes are quite a bit shorter, like maybe 3 or 4 questions instead of 7 or 8, something like that.
Is derivative skills 1, is it just up to the card roll, or does it go to the table?
So derivative skills 1 basically is everything in regard to derivatives except for when we started the chain rule.
Okay.
And then, of course, we just transitioned over to a product rule.
Okay, so it's all of these.
Yeah, so it was 2 days. Yeah, so basically, if you look at that chart of all those derivatives, like if you know how to find the slopes of the tangent lines for all those functions in their non-composite form, you'll be good. And of course, we've been practicing those even when we were doing composite as well. Anybody else with a question? Okay, one last thing I want to mention to you guys. You guys are the red class. And so our Unit 1 test is next Wednesday, right? Next Wednesday. Okay, so here's how the unit tests in here work. I try super hard to time these unit tests correctly. It's hard to get it correct as far as the exact amount of time. The way that I do it is very simplistic. I write the test, I edit the test, try to make sure there's no little typos or anything, and then what I do is I sit down and I say, I'm going to take the test, and I'm going to take the test as quickly as I can. Still, obviously, try to get everything correct, right? So I sit down and I personally try to take the test as quick as I can, and then whatever time that it takes me, I take that time and I go times 4, and that's an estimate roughly of the time I would expect a student who's never seen this material before to take that test. Does that make sense? Okay. So what I do is I shoot for, since we have 50-minute periods and we have a lot to assess, I shoot for exactly 50 minutes. Okay? So here's what that means. Some of you are going to take right about 50 minutes. A few of you might take a little bit less, and there's some of you that are going to take more than 50 minutes. And I want to allow for that. What I don't want to have happen is have you get to the end of the period and say, Mr. Anderson, I only have 2 left. Could I come back after school to finish it? The answer will every time be, sorry, no. So to allow for the potential that you might need a little extra time beyond just the regular 50-minute period, you can take part of lunch on that Wednesday during red to start, okay? And so I will give, so lunch is like roughly 50 minutes, right? Depending how you count the passing periods or not, whatever. And so if you want to give yourself an extra 25 minutes to make sure that you don't get to the end and panic, only 1 minute left and I still have 3 questions to go, like that whole routine, if you want to show up 25 minutes early essentially, you are highly encouraged to do so, especially on the first test, because you don't know exactly what your pacing is. I would strongly encourage you to run down to lunch, grab your lunch, come back up here. You can eat your lunch and do your test at the same time. Or you can wolf your lunch down real fast and then do your test, whatever. Does that make sense? I want to allow you the time to chew on the test and, figure it out as opposed to just like panic time. The test is not incredibly long. I've tried to be incredibly economical with it. The only thing I've ever done with it is made it shorter to fit within our ever-shrinking class periods during the hour. So does that make sense? I'll remind you that again as it gets a little bit closer, but I thought I'd put that bug in your ear right now. You all good? Okay, fair enough. So let's move. Let's go ahead and check out our activity for the day. And it is right here. Yes, the quotient rule. So how many of you have heard of the quotient rule? Maybe in a pre-calc class. I think some of you have for sure. Okay, so last time we looked at how to find the derivative of a product, and I think I mentioned that one of the big challenges with finding the derivative of a product is actually identifying that it is a product, right? Too many times people just blast right on past that, and they forget that it is a product, and they should be doing the product rule, but because they didn't recognize that it was a product, there's some struggle, right? For whatever reason, people never seem to misidentify this. I don't know why that is, because maybe it says a fraction, it's written vertically instead of horizontally. I don't know what it is, but most folks don't have a hard time with this. I wanted to show you the rule, and then we'll have an easier way to remember this as well. So here it is. The derivative of some function divided by some other function equals that? Kind of a handful to memorize. That's why I don't memorize it. Ready for the easy way? I'm sure you've heard of this. Some of you have at least. Low d high minus high d low over the square of what's below. So what do you think about that? It rhymes, doesn't it? So since it rhymes, hopefully it's easy for you to remember. What does the word low stand for? Denominator. Yep. What about d high? Derivative of numerator. And of course, high would be numerator, d low would be derivative of denominator, and then over the square of what's below is the denominator, right? So squaring the denominator. And of course, as I was writing that nice little symbolic version of this, what's going on in my head? Low d high minus high d low over the square of what's below. And if you try to say it and it doesn't rhyme, you messed it up, right? So if you say high d low minus low d high over the square of it's not going to rhyme. You messed it up. You got to flip the order around. Really important thing to understand here is with the product rule, because it's 1d2 plus 2d1, the ordering with the addition doesn't matter, does it? 1d2 plus 2d1, or you could do 2d1 plus 1d2. The ordering doesn't matter. But here, because it's subtraction, low d high minus high d low over the square of what's below, the ordering with subtraction certainly does matter. And so you want it to rhyme, right? You want the order to be correct. Okay. So I'm kind of hoping that you guys can take this ball and run a little bit with it. So why don't you try number 1? It's clearly a quotient. See if you can execute this correctly and put things together with the quotient rule. Carter, what's up?
I'm wondering if I did this part right for the
Low d high minus
this part right here.
high. So this should be cosine of 5x.
5x.
Right? So when you open up that outer box, the inner box remains intact.
Right, okay.
Then you take it out and find its derivative.
So it'll be there, like 5x.
Yeah, cosine of 5x. Now, there's something else to consider here. This cancellation is no bueno. Because at the top is a difference. You can't cancel part of a difference. You can only cancel part of a product. And so very rarely, only in certain circumstances, will there be a simplification like that with this.
Okay.
So be super careful with that.
Okay.
Okay, so let's check out number 1, an answer for number 1 going up there. Oh, I froze it. Sorry, you keep writing. So let's compare what you got with what's going up on the screen.
This is right.
See if it makes sense to you.
Isn't it negative cosine?
Maddie is writing this.
Oh, I was like,
I have the super awesome connection.
Is
with
it
her.
negative cosine?
Will it? to write.
No, it's positive.
Her writing is way nicer than
Oh,
mine.
that's right.
You should have known it wasn't me. Okay, so what do you guys think about that as far as the answer goes? I heard somebody say, isn't it negative cosine? The derivative of sine is,
Cosine
it is positive cosine. And so I think that minus, I think that numerator looks good as is. Questions, Zach?
I followed this, but sine of 5x squared is the same as sine squared of 5x.
Correct.
Right?
Yep, good notation there for sure. Good question on that. What else? Caleb?
Would you want us to simplify it anymore, or?
So what could you do? You could factor out an e to the x. What else are you thinking?
Just denominator with like.
What would I actually do to that denominator, though? What are you thinking?
Like, I had it as,
Oh, I'm looking at, oh, I see, okay, so you're being a little bit overzealous. So, low D high, so D high means derivative of numerator, minus high D low, that means derivative of denominator, and then over the square of what's below, you just leave it as the square of what's below. You don't take it another step, or if you did, you actually did it right, but you don't do that.
okay.
You don't do that. Yeah, good question, good question. What else? Come on. Anything else besides how do I do it? Magic. Okay, so I think Maddie has a real nice example of an answer there. You could have done some factoring of either the x's, and I don't know if any of you are like super fancy and know how to do some trig identities with sine of 5x, maybe, I don't know. I don't think I would do any of that stuff, but whatever, it's your choice, it's your break. Okay, cool. So if there's no other questions, let's look at number 2. It says find the slope of the line tangent to the graph of h of x. H of x looks kind of intimidating. I think it's pretty doable. We want to find this when x is 1.
Can we use a calculator?
I don't think you have to have it. There's going to be like a pi over 4 hanging out in there somewhere, and there might be some awkwardness, but I don't think it'll be too bad. I would definitely try it without a calculator as much as you can. We will eventually break the calculators out. Don't worry about that. So, okay. I think that pi over 4, that's what I was thinking. There would be like 1 pi over 4 in there somewhere. Jed, how you feeling about that one? Pretty okay? Okay. Well, you didn't need to do all the square root. Perfect.
Why is it do that? What? Confused.
Well, so secant, isn't secant the reciprocal of cosine?
Did you get -4?
Reciprocal of cosine.
Oh, wait.
So cosine of pi over 4 is
I'm
1
dumb.
over root 2.
I'm so...
So
That's my
secant
fault.
of pi over 4 would just be root 2 squared.
Oh, well, that's awkward.
We were doing one over 10.
That's my fault.
Oh, you had the wrong reciprocal. Got it. Got it.
You know.
Gotcha. Sorry about that. You think you have it? I don't have the answer memorized.
Kind of.
Kind of.
This is Reese
How would I simplify that?
Reese is lying?
Oh my gosh, I'm sorry.
A trig line. No good. So this is asking you to go one more step. I can clearly see you've done a quotient rule, so that's good. It wants to know the slope of the tangent line at x equals 1. So you're going to have to handle the at 1 part.
You have to actually solve it, or can you just
So it kind of depends on what kind of a question we're talking about, but I will say that I would want for you to be able to simplify it. I wouldn't want you to look at it and say, there is no way on earth I can do that. Hopefully you can.
This is C check. You did math wrong. 94 minus 10 is 14. 30, wait, 3 times 8. Yeah, you did the product rule wrong, or the power rule wrong.
Cosine to the negative. What's the word? How did I do the power rule?
Just 3 times 8 is 24.
My
It's 1 over, so. That's if you're finding an angle, yeah.
This is a lot harder. That's equal to root 2.
So I went ahead and wrote up there what I think the derivative is in terms of x. And again, I was just thinking low d high minus high d low over the square of what's below as I was writing that. So we got to finish this still, but any comments or questions about any of the little parts in there? There's a lot, so try to be precise about all the little parts and where things are supposed to go. Be happy to field any questions before we move on. Could I ask you a question? Would you guys agree with me that like the low D high minus high D low over the square of what's below was actually like borderline the easy part, and the plugging in of the one was the hard part?
Yeah.
Maybe? You might disagree, and that's okay. As I was walking around, the most of the discussion was like, what's tangent of pi over 4, and what's secant of pi over 4, and that kind of thing. So
Wait, what do you have pi over 4? What are you secant squared there?
chain rule.
Chain rule. Oh, do you
So-
chain rule that?
So ddx of
Okay.
tangent of pi over 4x, what I'd want to recognize is that because the input is not just x, it's pi over 4x,
It used to be 10.
the chain rule factor will be something other than 1. It'll show up. So the big box would be tangent. So the derivative of tangent of something is secant squared of something. But then I also have to consider always, no matter what, I've got to multiply by the derivative of the inside, and the derivative of the inside would just be pi over 4.
Okay,
Does that part make sense?
that makes sense.
Okay. There's a lot of details that need to be handled correctly. Okay. Anybody else? Questions or concerns about a detail or something? All right. So then if we're trying to find the slope of the tangent line at 1, I just need to plug in a 1. So it would be h prime of 1 equals, and I'll do some of this in my head because some of it is fairly easy. The rest of it, there might be some hard parts. When I first plug in, isn't it essentially 8 minus 10 at the start? So negative 2 times pi over 4. And we were talking about this at this back table. Here's how I do it, and I don't know if this works for you or not. To do secant squared of pi over 4, here's what's going on in my head. I'm thinking secant is the reciprocal of cosine, right? So I can operate from that perspective. What's the cosine of pi over 4?
1 over root 2.
1 over root 2. Now I got to do the reciprocal of that. What's the reciprocal of 1 over root 2?
Root 2.
Squared
2.
2. So all of this is just times 2. Is that okay? All right. What's tangent of pi over 4? 1. Good. And then, of course, that's essentially 24 minus 10, so that's 14. Down below, it's 8 minus 10 again. It's negative 2 squared, and that's 4. So let's see here. I'm coming up with, well, gosh, that's just negative pi, isn't it? Negative pi minus 14 over 4. So easy, right? No, come on, it's not that easy. There's a lot of details. It turned out to be an okay answer, but a lot of details to get right there. Okay, questions, concerns? Anything I can do to help you? Carter.
I think I know what I got it, but like the secant squared, like loss of pi over 4 on the other side.
Yeah, so that just comes from, that's the d high, right? And the low d high minus high d low is the d high. So high is tangent of pi over 4x, right? So when I do d high, that's d dx of tangent of pi over 4x. And so really the key step here is recognizing that this is a composite function, right? So if it was just tangent of x, I would say not really a composite, right? But because the input is something more complicated than just an x, we'd say, okay, this is a composite. And then I like to think about it like the boxes. If this is a composite, what's the little tiny box on the inside?
Pi over 4.
Yeah, and what's the big box?
Tangent of pi over 4.
I'd say tangent of something, right? So we have to start with the big box. What's the derivative of tangent of something?
Secant squared.
Secant squared of that something, right? So secant squared of that inside box. And then when I open that and I see, oh, there's a pi over 4x box in there, this is when I multiply by the derivative of the inside. And so was anybody kind of thrown off by the fact that the coefficient was pi over 4 instead of like 9? Kind of feels like a different sort of coefficient. But if it was like a 9x, the derivative of 9x would just be 9, wouldn't it? And pi over 4 functions in the exact same way. It's a more complicated constant, but it's still just a constant multiple times x. So we would multiply by the derivative of pi over 4x, which is pi over 4. So really, the short answer, Carter, is it's a chain rule factor. But it is kind of weird because it's pi over 4. And sometimes I think we think pi over 4 is a variable sometimes, but it's a constant. It's like, as you know, a little bit more than 3. Did I answer your question well enough? Okay. All right. Anybody else? Okay. I'm so excited. I don't know what's coming next. Let's find out. Oh, yes. Oh, yeah, I'm so excited to do this one. So use the quotient rule to show that d dx of tangent of x actually is secant squared, right? I mean, like a week and a half ago, I just gave you this whole list of derivatives, none of which I really proved all that much to you. And I thought we'd take one of these and show you how you could prove a lot of those trig derivatives. So it says, use the quotient rule. That is a massive hint. The only problem I see here is, if I'm going to be using the quotient rule, shouldn't I be doing the derivative of a fraction? I don't see any fractions anywhere. What could I do? Oh, that's so we're going to say that tangent is sine over cosine. So if I do the d dx of tangent, I'm really doing the d dx of sine over cosine. Perhaps now you can see the need for the quotient rule. See if you can take that and run with it and somehow arrive at secant squared. You know what the answer should be, right? This is one of those identity type exercises. So see if you can get there. The quotient rule, unfortunately, though it would work, would be the long way around. And one of your friends is going to say, it only took me like 10 seconds. And for you, it took 5 minutes. Okay? First of all, can you empathize why someone would look at number 4 and think, quotient rule? You can see that, can't you? It's fraction. There's a x in the denominator. Totally see why somebody would do that. And it would work fine. It really would. It would just take too long. So what we're going to do with stuff like this is we are going to try to avoid falling into the quotient rule trap. And we're going to do a little rewriting when possible. Does anybody have a suggestion? Can anybody see how we could get out of this quotient rule trap and get into a much easier derivative?
Move x cubed to the top.
Yeah, get that x cubed out of the denominator. What do you guys think that would look like if I did move that? Can you tell me what we should write?
2/3 x to the negative 30.
Nice. Okay, good. I've found a few folks over the years feel like this 3 right here has to move with the x cubed. Like if the x cubed is going, they feel like the other 3 has to go as well. It does not. It really ought to stay exactly where it is. So, do you see how now we've rewritten this? Do you see how this is clearly not a quotient rule anymore? What is it? It's just a really basic power rule, which I'm sure you've probably all done in your heads already. What is y prime? Negative 10 x to the negative 4th. So you see what I mean? Like if you do a rewrite, basically it takes you 5 seconds. Whereas if I didn't rewrite, oh my goodness, think about this. This would be a different way of approaching it. I could say low. What's d high?
0.
People mess that up a lot. They say d high is 10. But that's a constant, so d high is 0. So low d high minus high. What's d low?
9x squared.
All divided by the square of what's below. So it'd be 9x to the 6th. I'm even cutting steps here. So the first one is 0. So this is negative 90x squared over 9x to the 6th. Has anybody ever messed stuff like that up?
Oh, yeah.
Yes, we all have, right? So then I'm thinking, what do I do? Well, negative 90 over 9 is negative 10 over x to the 4th. And eventually you can see I get there. Maybe you can see why there's a lot more steps to be messed up or succeeded with on the right side. Whereas a quick rewrite, no quotient rule, it's happy, right? Why don't you look at number 5? We'll finish with this one. This is another quotient rule trap. Maybe it's a little bit less obvious. Do a quick rewrite if you can, and then try to differentiate without using a quotient rule. This will not always be possible. Sometimes, like the other examples we've done, you had to use the quotient rule. There's no avoiding. In a case like number 4 or 5, definitely suggested. Throwing away sweet potato fries. You want one? I need to brush my teeth. Sorry. Oh. those student enterprise or just regular ones?
Just regular.
Oh, wow, student enterprise. In my opinion, were those pretty good? They looked like they had some good seasoning. Okay, anybody just want to say it? What do you think y prime would be here? 2x to the negative 1/2. I agree. So the rewrite would look like this. Of course, this is x to the 1 down there. And when you're dividing bases, you subtract exponents. So this would be 4x to the positive 1/2, because 3 over 2 minus 1 is 1/2. And then you'd find your y prime. 1/2 times 4 is 2. Subtracting 1, there's your new exponent. Hopefully you can see that that does make it easier. I hope that you'll take that and run with it. Goodness, I kind of don't know what to do with myself. We haven't finished early ever. We have like 4 minutes left.
Adds up 7 up to 9.
That's a great idea. However, if anybody has anybody's concerned about anything on their quiz tomorrow, the derivative skills 1, is there anything you want to talk about? I mean, any thoughts? Yeah, Nate.
Not about the quiz, it's going to be taking from last time.
Yeah.
So like, we have our workout.
So your coach has high priority. They're not allowed to require that. Just like I'm not allowed to say, yeah, you have to be there. Otherwise you fail. Yeah, but your coach knows. Coach, I need 25 minutes. Yeah, she wants to talk to you about it. We need to do it. You gotta fix your quiz, right? So go through the couple that you missed and rework those stuff in the practice section. I'll be around 7. Sometime after that, we'll use. Any other questions on quiz material? Yeah, Kaylin.
What is presentation 4 over? Is it over like?
Actually, I accidentally showed it to you. It's
but is it like which section of material? Is it unit 2?
I think it's more unit 1.
Is it?
Let's find out. So presentation 4. Yeah, presentation 4 is a continuity question and an IBT question. So I can tell you why I put this in where I did, knowing that your test was going to be next week. This is a great test review, couple of questions. So yeah, this is definitely unit 1.
Okay.
Yeah. I'm trying to think. And we do, oh, and by the way, we do have a review day prior to the test. So next Monday, right? Next Monday we'll have a review day that, or it's either Monday or Tuesday. I can't remember which day it is, but we do have a review day built into the schedule for that. So I got a bunch of practice material in your packet for that. So, anyways, yeah. All right. Well, I've said all I need to say. Have you said all you need to say? I'm good. I'm good. If you're ready to go, go for it. Have a good rest of your day.
Thank you, Mr. Anderson.
Thank you.